So I'm going to try to go over periodic trends really quickly. Hopefully a 15-minute video. I'm trying to make not 20, but you never know. So we're going to pick up with attraction. We've already discussed how the attraction decreases as we go down a group. And the reason that is because I have more energy levels. And so since I have more energy levels, that means my valence electrons are a higher distance away from the nucleus. And the higher the distance, so more energy levels, means more distance between the valence electrons and the nucleus. And more distance is going to mean lower attraction. Well, there's one more thing that we really didn't mention yet, and that's referred to as shielding. So the further it is away, it also has more shielding. And what shielding is when you look at these interior electrons. So beryllium has 2 interior electrons, 2 electrons that are between the valence electrons and the nucleus, and magnesium has 10 interior electrons between the valence electrons and the nucleus. And so these interior electrons block some of that attraction. So as we go down a group, it's really because of the distance and the shielding that cause the lower attraction. When we talk about across a period, we're talking about proton-electron pairs. And so in this case, magnesium and sulfur has a higher number of proton-electron pairs. And the more proton-electron pairs we have, the more attraction we have. My analogy for that is if you have 2 pencils. If I'm magnesium and I have 2 valence electrons, 2 proton-electron pairs, I'm going to represent that by putting 2 rubber bands around the pencils, connecting them together. If I try to separate them, it's not too hard. However, if I do sulfur and I have 6 rubber bands holding the 2 of them together, then if I try to pull them apart, it's quite a bit more difficult because now I have that attraction between the 6 valence electrons and 6 of the protons. It holds them more tightly together. It has a lot more attraction. So attraction increases as we go across a period, and it decreases as we go down a group. Now, something else that this impacts is radius. And so our radius is essentially the distance between the nucleus and the valence electron. We figure it out in a different way, but I don't really care about that right this moment. So our radius is between the nucleus and the valence shell electrons, just like they always are. So beryllium is obviously going to have a smaller atomic radius than magnesium because it has less energy levels. Sulfur, because it had a higher number of proton-electron pairs, is going to be smaller than my magnesium because it had more attraction. Still going to be bigger than my beryllium because it has an extra energy level, but so my atomic radius is going to decrease as I go from left to right, and it's going to increase as I go down a group. Basically, if there's more attraction, it's a smaller radius. So, higher attraction equals lower atomic radius. So what about when we talk about ionic radii? And so when we talk about an ionic radius, what we're talking about is when we form ions from these elements. And so you can see here that I have magnesium and I have sulfur. And so in this case with magnesium and sulfur, I'm going to look at magnesium first. So I'm going to look at our metals. So when we have metals, we know that the metals are attempting to lose electrons. This is also why, as far as metals are concerned, as the attraction decreases, then its reactivity will increase. and that's because metals lose electrons. And so then with this, if my magnesium becomes an ion, it goes from its neutral atom with having 12 electrons, 12 protons, to a neutral atom, it's going to do whatever's the most energetically favorable. So the two options it has is it could either lose 2 electrons or it could gain 6 electrons. It's trying to get a complete outer shell, so it's energetically stable. And so the easiest thing to do, thing that requires the least amount of energy, is for it to lose 2. So that's exactly what's going to happen. And so again, as far as talking about the ionic radius, it's easy to see why the ionic radius for metals is going to be smaller than the atomic radius, because we're losing energy levels and we have more protons than electrons, and so both of those things are going to cause more attraction than just our regular atom. Also, because I lost 2 electrons, I now have more protons than electrons, and I have 2 more protons than electrons. So that gives magnesium ion a charge of +2. So now let's look at nonmetals. And if you remember, nonmetals gain electrons. And so, because they are gaining electrons, higher attraction for them means higher reactivity. And so when we have our sulfur, what's going to happen is it's gaining electrons. And so instead of 6 electrons, again, it could either lose 6 or gain 2. And so in this case, it's going to gain 2. So it now has 8 electrons. And what this means is that now it has 18 electrons and 16 protons. And so it now has more electrons than protons. Since it has more electrons than protons, it's going to be a negative, and it has 2 more electrons than protons. So sulfur will have a charge of -2. Now, because there are more protons than electrons, what's going to happen with our atomic radii? Well, my atomic radii is going to, or my ionic radii is going to get larger. So atomic radii is when we're talking about a neutral atom. Ionic radii is when that atom becomes its ion. So with nonmetals, our ionic radius is going to be, I'm going to erase that, sorry guys. My ionic radius is going to be smaller than my atomic radius. When I talk about metals, then I just said that wrong, didn't I? I apologize. My atomic radius is going to be, less than my ionic radius. When I talk about metals, my ionic radius is going to be smaller than my atomic radius. Okay? So then, moving past that, we're going to talk about some of these trends. And so we already talked about the atomic radius. And we said the atomic radius is going to increase as we go down a period, and it's going to decrease down a group, and it's going to decrease as we go across a period. And the reason we said it's going to increase down a group is because there's more energy levels. There's going to be higher distance, higher shielding, which means lower attraction, and therefore a larger radius. As we go across a period, there's going to be more proton-electron pairs, which means there's going to be more attraction, which means we are going to have a smaller atomic radius. Remember that we said with our atomic radius, higher attraction equals a smaller radius. As far as our ionic radius, we just discussed this up above. And so if you need to review that, then look up above. Our ionization energy. Ionization energy is the energy required to remove an electron. And so if you understand what an ion is, this makes it pretty simple. If we have a higher attraction, it's going to require more energy to remove the electron from the atom. And so with this, our ionization energy is going to decrease as we go down a group. The reason it's going to decrease is because as we go down a group, we're going to have higher number of energy levels. We're going to have a higher distance. We're going to have higher shielding. Which means we're going to have lower attraction. And because we have less attraction, it's going to require less energy to remove the electron from the atom. As I go across the period, my attraction increases. Why does my attraction increase? Because I have a higher number of proton-electron pairs, which means higher attraction, as we just said, which means it's going to require more energy to remove the electron from the atom. The last trend we need to discuss is electronegativity, and electronegativity happens in covalent bonding. In covalent bonding, atoms are sharing electrons. The thing is, though, is that the atoms have various differing amounts of attraction. For example, as I go down the group between oxygen and sulfur, we've already talked about this numerous times. As we go down the group, we have a higher number of energy levels, which means more distance, more shielding, less attraction. And so with that, sulfur is going to have a lower pull on the electron. And so that's what electronegativity is. Electronegativity is the pull on the other atom's electron. Since they're sharing these electrons, then sulfur is going to have less of a pull on oxygen's electron that it's sharing, and oxygen is going to have more of a pull on sulfur's electron that it's sharing. So the electrons are going to ultimately pull in the direction of oxygen. So it's sharing, but it's not sharing equally. That's what electronegativity is which one has a stronger pull on that electron. And in this case, it's going to be oxygen. When we go to across the period, again, comes down to attraction. Because we have a higher number of proton-electron pairs as we go from left to right, that means that we're going to have a higher attraction. And since the electronegativity is the pull on the electron by the nucleus, then higher attraction means that we're going to have a higher electronegativity. We're going to have more of a pull on that electron. And so fluorine is going to have a higher electronegativity than carbon does. The last thing to address is just the different trends as we handle the periodic table. And so do keep in mind that any question that you answer, if it's going down a group, you must address distance, shielding, their impact on attraction, and then whatever the answer is for your trend. If you're going across a period, you must address the number of proton and electron pairs and how they impact attraction, and then answer the question as far as your trend. So we notice that attraction decreases as we go down the table, increases as we go right. Atomic radius increases as we go down and decreases as we go right. Ionization energy decreases as we go down and increases as we go right. and electronegativity decreases as we go down and increases as we go right. Pretty much what we're paying attention to is we notice that with the exception of atomic radius, everything is going to go in the same direction as attraction. If attraction is increasing, it's going to require more energy to remove the electron, and it's going to have a stronger pull on the electron if it's sharing. That means that the atomic radius is going to increase. It will be pulled away from the nucleus. Hope this helped. If you have questions, let me know. Otherwise, have an amazing evening.